Good afternoon. This is David Robinson with Design Master Software. Welcome to our training. Today we are going to be looking at the circuiting command in Design Master Electrical. So welcome everyone who's having a chance to join us live. We are recording these and we'll be posting them to the website, so anyone who didn't attend it can see it later, or you can review it. We're working on getting those posted. There is a chat box in your Blizz interface, so if you have any questions, feel free to type them in the chat. I'll kind of keep an eye out there and try and answer those questions as they come in. Otherwise, we're going to talk about the circuiting command. I'm going to do a half-hour session on that. Then we'll kind of open it up for questions on that or any other general electrical questions you have. And then after that, if there are no additional questions, I probably can keep talking on the circuiting command for the rest of the hour. So let me pull up AutoCAD, and let me pull up my notes, and we can begin. So we have the circuiting command. It's in the circuiting section on the ribbon. It's available on the pull-down menus as well. And this is the command that we are going to be looking at today. So we're just going to kind of walk through as much of this as we can cover. So this command is focused on working with and making modifications essentially to your branch circuits in your project for getting all your settings, breaker sizes, wire sizes right on those. This is not for feeders. Feeders, if you go to a circuit that has a feeder on it, like this transformer, we disable the vast majority of options in the dialog. To actually make changes to the feeders, those are always done over in the definition of that piece of distribution equipment. So like this transformer, if we wanted to change this feeder, you'd have to go hunt down that transformer and make your changes here. We're not going to take a look anymore at that, but just be aware that if you're working with feeders, go into the distribution equipment, make the changes there, because we don't let you do it over here. There are a couple commands, buttons we have on here. They're just convenient buttons. They're available in other places in the software, but we have them here so that if you need to get around to other places, you can. The first is what I just showed, this edit button. So when you choose your distribution equipment, you can obviously circuit to it. If you need to make any changes to it, you just press edit and we'll pull that dialog up for you. So that's a convenient way to go make changes to your panel if you need to make an adjustment to the bus size or anything like that. We also have the Move Circuits command. So this button just flips you over to the Move Circuits where you can swap and copy and merge. There's probably a whole session that we could do on this at another time. But just know that if you do need to get to the swap circuit or copy fixed loads, you can do that here. And then the circuiting button here takes you back. And finally, just in terms of the convenience buttons we have the Draw Home Run and Loops and the Draw Home Run command. These are exactly the same as the commands here, the Draw Home Run and Loops and the Draw Home Run Only command. So if you've circuited a bunch of stuff up and you want to start drawing home runs, you can do it straight from the circuiting dialog. You can also do it from the ribbons and the pull-downs as well. So be aware those buttons are there, just a convenience. They're not, special to the circuiting dialog, but we do have them there if you need them. The basic functionality for this dialog box is to connect devices to your circuits. So you've got your list of circuits here, and you can connect devices on your project to them. So I'm going to take a panel which has an appropriate voltage, and we can click the Circuit Devices button. You can go select a couple pieces of light fixtures, and it will connect them. It's worth noting you can also double-click. You won't see it, but I'm going to double-click here. I can get my double-click to work, and it'll do the same thing. So you can either select the button, or you can double-click. Down at the command line, when you are circuiting, be aware there are some options happening down there. So we're trying to give you a little bit of information about what's going on. As you connect devices, we update you with the current load on that circuit. So I put a couple more light fixtures on that circuit. We've got a connected load of 0.5 kVA. Throw on some more light fixtures. Now 0.715. It'll keep letting you know what your connected load is. It'll also give you your breaker size, so that actually if you bump up to the next breaker size, you'll see that here. It also says that if you press enter once, it'll increment to the next circuit. So if we press enter, we can go to L15 and we can make start circuiting to that circuit instead. And if you press enter twice, it takes you back to the circuiting dialog to go make other changes here. That's the circuit devices button. We also have this circuit to phase button. This is for connecting devices to specific phases of a multi-pole panel. If you've got the common uses for that are when you've got site lighting and you've got the 2-pole site lights that you're connecting to a 3-pole breaker and you kind of want to rotate them around it to balance out the load, you can do that. Or if you've got multiple receptacles or light fixtures that you want to have on a combined home run, and so you want to have the common trip, that you can connect them that way. So I'm actually going to create a 3-pole breaker here to demonstrate that. So if you have a 3-pole breaker, when you click circuit to phase, the first thing it says is, hey, which phase are you connecting to? So it knows where we're actually making our connection. I'll take the B phase here. We can select a couple of light fixtures, and it connects them to that circuit on that breaker. We have new options at the command line now. If we press enter once, rather than incrementing immediately, it gives you a couple options. One is if you just press enter again, it goes back to the circuiting dialog. You can also do set phase by pressing S or selecting it depending on where you like to use it on the AutoCAD interface. We can also increment the circuit. So increment circuit will just go to the next circuit. Set phase allows you to choose a different phase to circuit to. So here we could choose to connect to the C phase on L111 there. Select those light fixtures. And when we go back to the circuiting dialog, you see that 9 and 11 have been filled in, so we've connected to those poles on that circuit. And then the A phase is currently empty. When you have a breaker like this where you've got loads on different phases, if you run the change number of poles command on it, we'll actually keep everything on the same pole and just make the breakers into single pole breakers. You can also take devices that have been previously circuited, and I could take these and group them into a 3-pole breaker. So if I change this to a 3-pole breaker here, puts everything together on that 3-pole breaker, but it actually keeps them on the circuits they were on before. So they're still separated between those poles, just on a 3-pole breaker. That's the functionality that we're trying to handle there is that the NEC requires if you're combining circuits and you're combining the home run, the neutral in the home run, you need to have a common trip, and so this is how you handle that with our software. You don't want to just combine them. You actually have to have a common breaker for them so that if one trips, they all trip together. So that's changing number of poles. We have commands here for just shifting things around a little bit. If you really need to start shifting around, the move circuits allows you to kind of swap just arbitrary locations. So that's helpful for that. But we do also have here the insert circuit and remove circuit, and this will just put a space wherever you have the cursor here. So I've got circuit 3 selected. I click insert space, and it shifts everything down, adding a space there. So we can just keep clicking insert space, and we'll get a bunch of spaces there. If you run out of room and you have stuff at the end of the panel, it won't let you put circuit spaces in because there's no room at that point. In the same way, you can remove a circuit, and if it's a space, it'll remove the space and pull everything up. If you run that on a circuit that's got stuff on it, it will complain and tell you, I can't do that. And hopefully then you'll figure out what you wanted to do instead. The other option we have for kind of rearranging circuits is the compress circuits command, which is down here. What this does is it takes all of the spaces and it pushes them all down to the bottom of the panel and all of your loads up to the top. So if we have, you've been doing a bunch of work on your design, and just over the course of the project, you've added things to circuits, removed them, and your panel's starting to look a little scattered in terms of where things are connected. You come in here, press compress circuits. It pushes all the breakers up, so all those lighting circuits go up to the top. All the spaces go down to the bottom. And this command also has one other useful feature, which is kind of not the intended functionality, but it does come in handy. Every now and then, on occasion, you get duplicate circuits. Like you'll have a 9-9 listed. And that's just our software with a bug. Any useful software is going to have bugs in it. Our software occasionally has a bug. And so occasionally you'll get an extra circuit in there. And typically you send it to support. You say, what do you do? And the first suggestion we'll always make, or the first thing we'll try before we make the suggestion, is we'll say run compressed circuit. Because if you do that, it kind of renumbers everything for you. So if you've got duplicated numbers, it'll figure that out and get rid of the duplicates. It also pushes everything to the top, so you might have to, put some spaces back in there, but at least you can get your project back to a working state again. So if you do run into that, obviously we try and keep those bugs out of the software. We remove them as we find them, but sometimes it's like, well, we don't know how that happened. This is how you fix it. If that doesn't fix it, then you can send it to us, and we'll make other suggestions as well. But that's at least a first thing to try. On the right-hand side here, we have all the information about the circuit. So we just display some information, about the circuit, so you know what the connect load, the wire size is on that circuit. And then we give you the option to set the breaker and the wire sizes for it. By default, all of this is set to size automatically. So we're pulling the loads and everything and figuring out what your breaker size based upon what's connected to it. But then you, as the engineer, always have the ability to come in and override this. And whatever you set here, this is kind of the final word. So if anything's set here, all your other settings are ignored, and we trust that this final spot is where you actually made the right choice. So if you really want to override things, you just come here and you can override whatever else is going on in the project. So if we set this to a 50 amp breaker, we're always going to get a 50 amp breaker regardless of what else we choose to circuit to it. Same with the conductor amps. If you choose a specific size wire, it's always going to use that size wire regardless of what's connected. And again, same for neutral and ground. You can choose a different conduit size, and we'll tell you the conduit fill. So if you need a larger wire for future expansion purposes, you can do that. If you want to, you can do a smaller conduit. Or you can just leave it to be sizing automatically. The layer system here controls the layers and colors that are used on the loops and on the feeder lines in the one-line diagram. So the default setting, they're all set to default to start, and that default is actually pulled from options as to what that layer system is. So if we go over to our options, we have choices here for what the default layer system should be for your circuits. And let's see if we can figure out where that is. Here it is. Default circuit layer system. We have a lot of options. So the first choice is same as distribution equipment. Basically, if you have a new panel, all of the circuits are new. Existing panel, all of the circuits are existing unless you override it. You can also change it to say, hey, I want all my circuits to be new or all of them to be existing unless I override it. And that way, if you have a new panel, you could have existing circuits, or existing circuits would look like they have new, existing panels would look like they have new circuits. So we'll leave that to be same as the distribution equipment. But then if you have a circuit that you want to change the layering on, this is where you do it. And this is, again, both for the looping on the drawing and for the feeder in the one-line diagram. So if I come to my air handler here, it's both here on the drawing, got that Homerun there, and then if I throw in my one-line diagram, right up there, it also has a feeder here that's representing that branch circuit. So if we go into circuiting and we change that from default, which is new, to existing, it updates this one automatically. It just kind of goes and tracks it down and changes that layering for us. When we update the one-line diagram, it'll also recognize that, and so it puts in the existing layering there as well. So that's how you control the layering of both your branch circuits in your one line and on your drawing. The general lighting circuit option controls whether we consider this a general lighting circuit. And so those are circuits that are doing the lighting that is covered by the demand factors in NEC 220.42. So basically, you have your general lighting. It's based upon, the NEC requires you to have a value based upon the area of the building. So the load at the panel level is chosen based upon the area of the building, but then you still have to circuit light fixtures to it and say this light fixture is going to be fed from this circuit. And so if you include the circuit, the light fixture load of what's connected plus the area load, you're basically double counting, and the load on your panel ends up too high. So if you set this to yes, what it means is, okay, I've got things connected to here, and we'll show that as a load on that breaker. But when we come to the panel level, we're going to ignore this load, and we'll assume it's part of the area calculation. So a lot of times, people end up with a bunch of zeros on their panel schedules, and it's usually because they've changed this setting at the panel level to have all of their circuits be general lighting circuits. And so if you do that, nothing is going to show up at the panel level, and then everything's zero. So this value you can change here for the individual circuits. You can also change it for the panel. So the default for what all the settings are on the panel. So typically in the panel, you want this set to no. And this is under the feeder and service calculations. Leave that set to no or to default, which should be no. And then on the specific circuits where you have general lighting, set it to yes, and everything works out the best that way. Now looking at description. You can fill in a description here. If I put in the description, say existing, it goes in the front of your circuit description. So you can always add a value here quickly to your circuit description. If you have a space and you type in something, if I want to call this a spare, it'll override what's there in space and spare. It's terrible names because they're just one letter different. So just make it a little more clear that there's a different value being displayed. So if you just have a space, we'll just totally replace the description. If there's a description from another circuit, a device connected, we'll add it to that. You can also click More, and this gives you additional options for what you're doing for your circuit description. You can set a prefix, which is what the default box is there. You can set a suffix, which will end up at the end of the circuit description. And you can also set a replacement if you don't want to use the circuit description that's being pulled in from your devices. So we could do pre and post, and then we'll have a longer circuit description with those values there. And then we can also just replace the whole thing. And even if you have a prefix or a suffix, it'll go away. You always have the replacement option so that you can override. If you're having to use the circuit description replacement a lot, then you probably can go to the device level and make some changes so that the defaults are a little bit better for you. We have the replacement there. There are times when you need it, definitely, and it's useful for those times. But if you're having to use it a lot, there's probably an easier way with the software, because we don't want you to spend your whole time typing in circuit description replacements. That's a bad use of the software. So if you are doing that, we'll probably in another time look at different ways you can get your circuit descriptions to fill in better. The starting phase is for circuits that are not on panels. So panels always go ABC, ABC as you go 1, 3, 5, 7. So you can't actually change the starting phase. It's disabled. It'll tell you what it is. This is B, but it's not going to let you change it. If I go, I'm going to make a switchboard. We will call it S, and we'll go to the circuiting. Now we don't have any odd even split. We just have a whole list of breakers. And they all default to being 3-pole breakers, and they all start on phase A. If you need to, typically what happens is you have some single-pole breakers here. And if you leave everything on phase A, your switchboard ends up totally out of balance, and that's not good for your design. So the way you make that adjustment is you come here and you can change the starting phase from A to B. So if I just add a load there, and then a load here, if we insert that switchboard schedule, we can see that it's pulling those phases for us. So we've set starting phase A of circuit 1 to circuit 1 starting phase is A, circuit 2 starting phase is B. So it's rotating. It's rotating them nicely for us. And I got the set fixed loads. This is where you can just force a value on your circuits. Generally, you want to put in your devices, connect them to the panels that way, so you've got your drafting and all your stuff on your floor plans matching up nicely with what's being connected to your circuits. But there are times when you have existing loads, and so you don't want to lay all that out. Or there's just stuff that you want to have as a load on the panel, but you don't want to do the drafting of the floor plan. And so here's where you can specify that. We have all of our load types listed, and you can specify the fixed load for all of them. For a couple of them, we have multipliers, where you can set the demand factors, or typically quantity counts if we're doing something like kitchen, where we need to know how many devices there are. If this circuit represents more than one piece of kitchen equipment, you could say this is 2 pieces of equipment, and then when it does the panel level calc, it'll pull up the right demand factor based on how much is connected, how many devices are connected to the panel. You also have the option for the circuit descriptions here. This is the same as what this More button does, just in this dialog also, so a different way to get to those circuit descriptions. I should point out, I will do it on this circuit here, that if you have multiple phases, if you have a 3-pole breaker, you get an option for circuit description on each of those phases. So typically, if it's like a piece of equipment, everything's going to go on phase 1, so it's all nicely labeled there. But if you want to do something on phase 2 or 3, you can add descriptions to those phases as well. Now, if you have a lot of data entry you need to do, we do have a nice set of shortcuts intended to make this a little bit easier. Some people, believe it or not, don't even use the drafting portion of our software. They just use it as a panel schedule program, basically an Excel replacement. So they do everything as fixed loads, and then they draft their stuff separately. So we have options to totally from the keyboard be able to make all of these changes. So once you have pressed the set fixed loads, you can obviously use tab. And so if I press tab, the cursor jumps between the different fields. We also have these letters next to all of these fields. And those are there because those are shortcuts to get to those fields. We have them grouped in threes. Apparently we added a new one. We need to fix that because they should be in threes. They're grouped in threes so that you can cycle between those couple with just that letter. So if I want to get over here to, say I want to get to these small appliance, the laundry values, if I do Alt, when you press Alt, it'll show all the underlines. Those are the letters you can press to go to those fields. And if I press Z, it'll go to the first one. If I press Alt-Z again, it steps to the next one. So I can cycle between those four without too many clicks. If I need to get back to the cooling loads, I can do Alt-D. So it'll, again, cycle between those three. So that way, you can take your hand off the mouse, use your keyboard shortcuts to cycle between the different fields and fill in a bunch of information. So I could put one there, and I could come over here and put in a load. Then if you press Enter, it will put the focus over on the circuit. So when you press up and down, you can actually go select a different circuit easily. You can also press Tab and go over to the even side, or Shift Tab and go back to the odd. From here, you can do Alt. Again, it'll highlight all of the fields that you can press for a command. And Alt-S will do Set Fixed Loads again. Come set some loads. Now you can press Enter and go choose another circuit. We also have this Next and Previous. Obviously, you can click those buttons and cycle between your circuits if you want to do this all from the keyboard. We actually have a comma and a period shortcut. They're kind of small. They're kind of hidden. This is actually common to a lot of our other dialogues. But if you look at your keyboard, it's kind of the two little angled brackets. So the comma is previous, kind of to the left, where left is backward, and then the period is the one pointing to the right, going the other way. So you can use Alt and those two to cycle between your circuits. So you can just step there to get to your other circuits, again, without taking your hand off the keyboard if you want to do a bunch of data entry. Is it as fast as an Excel spreadsheet? Probably still not, but this gets you a little bit closer if you do have a bunch of data entry. This is certainly not our most efficient workflow. That would be, putting your devices in and circuiting them, but if you aren't doing that for a portion of your project, this will help out with that.
David?
Yes.
Are those keyboard commands published somewhere if somebody wanted to have them set aside to reference?
We do not have a list of those anywhere. So maybe we should. If you do ever want to know what is available, just press Alt, and that will bring up the highlights. So if I close this, it should go away. So by default, none of the letters are underlined. If you press Alt, it then brings in these underlines if you look closely at your buttons and whatnot. And so that letter that's underlined is the one that you can press. So that's at least the way to discover it if you don't remember what you can do. The period and the comma, you just kind of have to know those because those are pretty tiny. And like I said, those period and commas, those are actually common if we go over to our panels. You'll see that the previous here has the comma, the next has the period. So from here, you can do the same thing and cycle between all of your panels. A couple releases ago, we had people asking for tandem breakers, and so we added those. Actually, people were asking for three things. They wanted tandem breakers, or they wanted peanut breakers, or they wanted mini breakers. It turns out all those are the same thing. So we call them tandem breaker. That seems to be close to a standard. Tandem or mini are what you can at least find on manufacturers' websites. I don't think any manufacturer officially calls them a peanut breaker. If you go into Home Depot, they have tandem breakers on their website. But Square D has some references to mini breakers as well. So we call them tandem breakers. If you do Create Tandem Breaker, it'll take this circuit 5, and you get a circuit 5A and a 5B. So you've got 2 breakers in that single spot now that you can connect. Not terribly frequent that you would use this for new construction. It's kind of existing stuff, either the existing conditions, or if you're adding, you need to fit another circuit in there, you don't have space on the panel, you can use that. And then if you put one in and you don't need it anymore, there's the corresponding remove tandem breaker command, which will pull that breaker and put it into a single. If there's stuff connected to both circuits, it ends up putting them both on that circuit for you, just so that they're somewhere connected. Rounding out our commands here, we've got the select circuit from drawing. You run that command, press that button, and here you can just select an arbitrary device, and it'll go highlight that circuit for you. So if you want to make a change to something and you don't want to go track down where it is on all your panels, you can use the select circuit from drawing. The inverse of that is the find circuit on drawing. That's where you've got a circuit and you don't know where the stuff is. You click find circuit and it'll tell you to say, hey, here's that circuit. It highlights it. It kind of draws a little arrow, a line between all the devices. To get rid of all that highlighting, you just run a regen and it'll disappear. It's not permanent. But that way you can find that circuit and then do whatever you need to do with it. And lastly, we have a couple of recalculate buttons, and these are mostly for convenience again, but they do exist on this dialog box. The recalculate panel load total, that's the same recalculate that happens when you update panel schedules. It says, do you want to recalculate the load between panels? This does the same thing. That's mainly to update these values here, because when you select your panel, we tell you what the loads are. And this will make sure that it's been recalculated to pull in any new loads you've added. We also have the recalculate circuit, which will take the circuit you've selected and make sure that it's calculated completely correctly. And then the recalculate all circuits, which will do that for all the circuits. Now, generally, 99.9% of the time, all of your circuits are always going to be correct. So our software, as you add and remove items, is updating the circuits automatically. The panels we don't do automatically. We have to run the panel load total just because that's a longer calculation. Circuits are pretty straightforward, so we do those as you make changes. That said, there are definitely times where something gets out of sync, and then you do have to come back and recalculate that circuit. And so you can run this command, and it'll make sure that it's pulled in all the loads properly for you. But that's generally a fairly rare occurrence that ever actually happens. And that's the circuiting command in half an hour. Are there any questions on that or anything else? Because I actually was able to cover everything I wanted to show you there in that little half hour.
So you're planning on showing the move circuits command at another time?
I was, but if I don't get any questions, we'll probably take a look at that, because that's something interesting. And we've got more time. Here's a question. How do you wrap the text in the description box so it doesn't run on the panel schedule? So that's a good question. You've got the longer circuit description, and you obviously you want your panel schedule to look nice. Our panel schedules do wrap the text, and our newer ones, if you're using any of the ones that are the yellow and red color scheme, have that built in. If you have older panel schedules or ones that you've customized, it might not have it. So you might have to make some changes. So first of all, just how that functionality works. If I type in a long circuit description, yeah, I'll put it here. So now we've got a longer description there. And if everything is set up right in your blocks, when you update your panel, it will automatically see that, hey, that description's too long, and it will add the space it needs to wrap that text. Now, there's a couple things you need to have set up in order for that to work. So if that's not working, there's two things that you need. If I use my customization, so our panel schedules are made up of a bunch of blocks. If I turn off object grouping, you can see that we've got the header block, which I've highlighted there. This circuit, each circuit gets a block. So the circuit 1 has a block, circuit 3, circuit 5, and then there's actually a tiny little block between each circuit which we use to expand those pieces. So you need to make sure that the circuit block is set up right and this little wrapping block is set up right. You can either take a look at those blocks from the drawing, or you can actually use our customization to open those blocks. So if I go to my distribution equipment schedule blocks, we've got here a list of all the blocks that make up those schedules. So you've got a block for circuit A, B, C, and then for the wrap. In the top right, you have the option to edit that block, and this will go find that block for you and open it up. So if I click Edit Block, here's that block. And we've got our attributes, which we're using to figure out where to put all the text. D1 is for the circuit description. D-end, which is over here, tells the software where to end the text and to start wrapping if necessary. So that basically defines the width. So you need to have the D-end so it knows to wrap the text. So you need to make sure that's there. And then in the circuit wrap block, you just need to make sure it's set to something so that there is a block so that it has something to stretch down. And that block is not very exciting. It's just a bunch of lines that it uses to stretch out. And that shouldn't actually have any attributes in it at all. So if you have a long description, hopefully it wraps properly automatically. If it doesn't, check that you've got the D-end and that the wrap block is set right. If you do have trouble tracking all that down, because that gets into kind of some tricky AutoCAD stuff to get set right, contact us and we can help you get that all set up properly. Because we have experience and can make it happen for you. I'm not seeing any other questions, so we will go off script and we will look at the move circuit command. So this command started its life as the swap circuit command to move circuits back and forth, and then we slowly added more and more functionality, so we had to rename it, and it became the move circuit command. Specifically, we added a copy fixed loads command, and then a merge, where you can take two circuits and put them together. So a lot of this is actually the same as what you have on the circuiting dialog. You have two panels and their circuits listed here. You've got kind of the left-hand panel and the right-hand panel. So you've got the panel that you're choosing and then the circuit that you're working with. So I could go to L1 and choose a circuit. I can also go over here. I can choose L1 and I can move stuff within a single panel, or I can actually choose a different panel to go to move stuff to a different panel. Both work. We tell you what your voltages are on your panel and your circuit, because sometimes if they don't match, we don't let you do some swaps and whatnot. The insert circuit, compress circuit, remove circuit, those commands are exactly the same as the circuiting dialog. We have them for the left-hand panel, also for the right-hand panel, so if you're moving stuff around, you can add and remove spaces easily. And then we've got the change number of poles, if you need to have a 3-pole breaker for any of your swapping, or take a 3-pole and make it a single pole. The change number of poles is available for that. So all of those commands are exactly as on the circuiting dialog, and the circuiting will take you back to that circuiting dialog. So the things that are special to this dialog are the swap button, the copy button, and the merge. So swap, and we kind of try and indicate with the arrows what's going on. So we swap the circuit on the left with the circuit on the right. So if I click this button, it's going to take this lighting circuit and this space, and it will swap them. It's not really a move circuit because there's always something on the other side that you're going to, even if it's a space. So that kind of just looks like we're moving from one to the other. So it looks like a move, but if I had chosen, say, a lighting circuit on the left and a lighting circuit on the right, we can actually just swap them. So it's not just moving one to the other. It's taking those two circuits and swapping the panels that they are on. And when you do this, we then update all of your labels, everything in your panel schedules and everything else. So that's swap. The copy fixed load has the little arrows going to the right. So copy fixed loads from here. So we take the fixed loads on the left-hand circuit, copy fixed loads to here. We put them over here on the right-hand side. So that's where, under circuiting, you've come in here. Say I've set a fixed load. We've got some receptacles, 1 kVA of receptacle on this circuit, and then we want to have 10 circuits that look like that. If we go back to move circuits, we can take that load here on the left, select the next space, or any space. It doesn't have to be on this panel. It could be on a different panel again. Click copy. It will take the fixed loads and actually everything on the right-hand side of this dialog, so all of the breaker settings and all the wire settings, anything you've done over here, it copies all that information to the other circuit. So all of your fixed settings, it moves over there. And it also increments on the right to the next circuit, so if you have a bunch in a row that are exactly the same, you can just keep clicking copy and it'll keep making the copies. So if I click copy, it copies it, increments to 17. Copy to 17, increments to 19. So if you have a bunch, you can set a bunch of them that way. Another place this is useful, again, because it copies everything here on the right. If I want to take this circuit and say, okay, this is a general lighting circuit, say yes, I can then copy that setting to a bunch of others. It might be an easier way, or if you've got some fixed breakers or something, you can do that with the move with a copy in the move circuit command. And finally, we have the merge button. So merge to here on the left and merge from here on the right. So the left circuit is the one that will stay with load on it, and we're going to take everything on the right-hand side, and we're going to take all the stuff that's connected, and we're going to actually connect it to the circuit on the left. So the circuit on the right is going to become a space, and the circuit on the left is going to have everything together on it. So here I could take everything on circuit 3 and merge it with circuit 7. So when I run that, circuit 3 becomes a space, circuit 7 has more load on it now.
David, can you run that the other way?
You cannot. Merge.
So I have to move my. If I wanted to go the other way, I'd have to move. Oh, well, see, currently you've got one panel. If I was merging from two different panels, would I have to arrange them so that I went from right to left?
Yeah. So it's just set up that the one you want to keep is on the left, the one you want to merge from is on the right. So you just have to get that order right, so our software will do it. I suppose in theory we could have two buttons, a left and a right. I don't know if that would cause more or fewer problems in terms of misclicks. So yeah, get the circuit that you're keeping with load on the left, the one you want to make a space on the right. And yeah, you can do that between panels. I've been doing everything up here in the odds. If you scroll down, you do eventually get to the even circuits. So if you have regular panels, the even circuits are just on the bottom. Just keep scrolling down to find those. Can you undo a merge or a copy with Control-Z? That's a good question. Unfortunately, the answer to that one is no. We do not have an undo stack on this command. So when you make a change, it's made, which can get a little bit messy, particularly with the merge, where you can take a bunch of stuff and merge it, and then disentangling it is a little tricky. And we do not have an undo for that. Take a look at circuit descriptions, since I alluded to that. So our circuit descriptions we pull from the devices that you've inserted, and then you can use the description to override it. But again, if you're overriding it a lot, you probably should make a change somewhere else. The first place that we always look is at the schedule level. So in your light fixture schedule, in your receptacle schedule, we have places there for the circuit description. So light fixtures, typically their load description is just lighting, but you can change that to whatever you want. We fill it in with lighting by default. So if you have a different load description here, we will fill that in. So if you wanted to have a default of LTG because you wanted to have smaller panels, you could do something like that. Every time we circuit that panel or that light fixture, we'll use LTG in the load description. For light fixtures, that's always coming from the project schedule. You can't override that for specific fixtures. So if you do need to override it, you then have to do it at the circuit level. Receptacles have a default panel description at the definition in the schedule level. So if you have a duplex receptacle, the default description is going to be a receptacle. But when you then place that receptacle on the drawing, you have the option to override that. So if I query a receptacle, we can actually come in here and say, okay, this is our default value, but I'm going to override that, and I'm going to call this, this is my dryer. So if you have something specific plugged in, you can add that, and you can obviously change the load as well if you want to. So at the individual receptacle level, you can override it, and then again at the schedule level too. And then equipment connections have a panel description. So each piece of equipment has its own unique description. The default is to have the panel description match the equipment callout. So whatever you use as your equipment callout, that's what's going to show up in the panel. There are times when the equipment callout has too much information or not enough, and then you can set a custom panel description. So if I wanted a longer description, I could have a longer description in the panel. That'll go in the panel, and what will show up on the drawing is just that air handler. So if I create this on the drawing, we've got the short description there, but then when I go to circuit it, it has the longer description at the panel. So that covers light fixtures, receptacles, equipment, which is generally what you have at the branch circuits. These descriptions that show up for feeders, you can't override the description at all, so you have to go to the definition of that device itself. But if I go to panel L3 and edit it, the default description is just the type of device and the callout, or you can override that and put in a specific description. You can add some sort of additional label there, and that'll then show up at the panel schedule for you. And those are the ways you can make changes to the circuit descriptions. Any other questions? Anything else you'd like to see? All right. Well, thank you, everyone, for coming. I'm going to go ahead and end this session, and we'll see you in a couple weeks to talk about one-line diagrams.